Hi, everybody. Welcome to topic number 13. This topic, we're going to talk about addition rules for probability. Okay, so let's take a look. Two events that are disjoint, okay, or what we so-called mutually exclusive. Okay, these wordings are very important. Two events that are disjoint or called mutually exclusive if the two events have no common outcome. So in my picture here, what you're going to see is face cards. All right, and you see sevens. Okay, so this Venn diagram shows there's no overlapping between face card and sevens. So that means these two events are disjoint or mutually exclusive. They have no common outcome. So the last picture I show you on the Venn diagram in topic 12, the number six I remember was actually in both A and B. So that six would be the common outcome between the two events. So mutually exclusive or disjoint simply means two events that have no common outcome. So addition rule for probability for mutually exclusive says, if two events E and F are mutually exclusive, then probability of E or F to occur that will equal to probability of the E plus probability of F. So the word or in probability means addition. The word or means addition in probability. All right. So if two events that are not disjoint, okay, if they do have a common outcome, then we will subtract the overlapping, outcome of the two events. Okay, we'll subtract the overlapping part. So the hearts and queen. Okay, there's one card that is queen of hearts. So that card, queen of heart, is in both events. So when we add them, when we add the probabilities of these two, then we were actually adding this seven of heart twice. So that's why we need to subtract. Okay, we need to subtract this happening that one time, that overlapping, we need to subtract one of them. Okay, so if I will say probability of E, which is heart, include the heart of the queen of hearts, plus probability of F, which is also including that queen of heart. So I actually add this one card twice. That's the reason why I need to subtract what's in E and F. Okay. So additional rule for probability, generally speaking, okay, if they are not disjoint, probability E or F of occurring will be probability E plus probability F, and subtracting that one extra time that we count, that one extra outcome we counted twice. That's why we got to subtract probability E and F. So let's take a look at some example. Okay, so let's say a standard deck of a card contains 52 cards. One card is randomly selected, so I'm drawing one card. Compute the probability of selecting a heart or a club. Okay, so that word or. So my two events are heart and club. So probability of heart or club of occurring got to be probability of club plus probability of, probability of hearts plus probability of club. So now you got to think, okay, does these two events disjoint or not disjoint? Do they have a common outcome? Is there a card in a deck that is also heart and club? Is there a card in the deck of 52 cards that are both heart and club? The answer is no. So that means these two events are disjoint. Okay, so if they're disjoint events, then I can actually find the probability. So don't think about like, because I'm only drawing one card, don't think about like there are so many hearts. Okay, think about like how many ways, okay, we can draw a heart. How many ways we can draw a heart. Okay, So there should be 13 hearts, okay? I'm only drawing one of them at a time. I'm only drawing one. So therefore there should be 13 ways to draw that one heart on a 52 possible outcome. Right? 52 possible outcome. It's not because it's not really because there are 52 cards. It's kind of hard to wrap your mind around it sometimes. Not saying there are, I mean, there are 52 cards, but there are 52 outcomes when you only draw one card, right? From a deck of 52 cards, you only want to draw one. So the total possible outcome of drawing a card got to be 52. There are 52 ways. There are 52 total different outcomes drawing one card from the deck. Plus, club is also 13 ways to draw them on a 52. Okay. So if you add up the numerator, there will be 26 ways I can draw a heart or a club on a 52 possible outcome. So I'm gonna keep my fraction just like this, okay? If you want to see the decimal answer, you can just type in 26 or the 52 in the calculator, and it will give you the decimal, which is 50%, of course. Makes sense because there are 4 suits in the deck. So heart or club is half, right? There's 2 suit out of the 4. So of course 50% makes sense. But I do want you to keep your answer as a fraction sometimes for the homework. Unless the homework says, round so many decimal places. All right, let's try another one. Okay, compute the probability of randomly selecting an ace or heart. Okay, so I'm selecting one card again, but this time I'm trying to select ace or heart from the deck. So or means we will add the probability of the 2 events. So probability of drawing an ace plus probability of drawing a heart. So you got to think, is there one card that is both ace and a heart? Well, there it is, right? There is one ace of hearts. So we have to subtract probability of getting an ace and a heart. And the reason why we're subtracting, think about this, okay? How many ways I can draw an ace? 4 ways. There are 4 aces in there. I'm only drawing one. So that means I got 4 different ways on the entire deck of 52 possible outcomes. Plus the hearts is, there are 13 ways I can draw a heart on a 52 deck, on the 52 cards, right? So total possible outcomes 52 again. So think about this, okay? That ace of heart is the 4, is one of that 4 out of 52. That ace of heart is also inside that 13 out of 52. So I already count the ace of heart twice. That's why I have to subtract that one way I can draw an ace of heart. That one extra time I kind of over added out of 52. So 4 plus 13 minus 1 is 16. So there are 16 ways I can draw an ace or a heart on a 52 possible outcome. Okay, so that's the way how we think about disjoint or not disjoint. Okay, so when we do, when you're dealing with the word or in probability, you got to think about, are the events disjoint or mutually exclusive, or they are not disjoint. Okay, let's try another type of problem. So this problem right here gives you a table. So a company classifies its customers by gender, location of residence. The data is gathered from a random sample of 1450 customers, okay? What is the probability that a customer is female? So got to read these problems very carefully. Probability just female. So we're not worried about where they live, just probability of females. Okay, so how many ways I can select a female? Well, females are all these. All these are females, right? So if I add them up, 65 plus 155 plus 234 plus 83 plus 86. There are 623 ways to select a female on the 1450 possible outcomes. Okay. I'm gonna keep it as a fraction for right now. If I want to know decimal, if you want a decimal answer, just divide this in the calculator. All right, read carefully. What's the probability that a customer, okay, so I'm selecting a customer, is male and live in the dorm? Or, see that word or? The or separate your two events. Or is female, live with her parents, okay? So probability of male dorm, I'm gonna say male dorm, male live in the dorm, or selecting a female living with the parents. Okay, so the or tell me to add the two. So I gotta think, okay, is this disjoint or not disjoint? Male dorm, okay, male dorm. Male live in the dorm, 278. Right there. Female live with the parents. So female live with the parents right here. So the two event is not, is actually not, it's actually mutually exclusive. It's actually disjoint because there's no overlapping outcome. So I simply just add up the two. Okay, 278. 278 ways to select that one male live in the dorm out of 1450 plus 234 ways to get that, to select that female living with the parents. So that should be 512. If you add up the numerator, 512 out of 1450. All right. Let me erase this real quick. Well, let's take a look. So or means we will add, right? Let's try another one. What's the probability that a customer is not male or, so that word or right here, that separate your events, not male or live in an apartment? Not live in an apartment. Okay, not male or not live in apartments. So this is two different events. Not male is one, not live in apartment. So if you think about, okay, not living in an apartment, that's everybody else. Okay, this is not the word and. This does not say not male and not in apartment. It's the word or. So you gotta think, okay, not live in apartment. Okay. Who does not live in apartment? So if you just think about not living in apartment alone, right here, these guys, those are not living apartment. All right. The first event is not male. Not male. Well, not male means not these guys under the first column. Not male is right here. I'm gonna use a different color, okay? Use blue. Not male. So you see, if I do it this way, okay, this is all not male. Horizontally is not live in apartment. So these green numbers are overlapped, right? So this two events are not disjoint because I did count some of these numbers twice. Okay. So you gotta be very, very careful. So not male. Not male. Right? It's all these. Not live in apartment is all this. Okay, so if I add them all up horizontally and add up not male, which is all this vertically, then I actually add 155, 234, 83, and 86 twice. So I can only add them one time. Okay, so that's the part I'm gonna subtract. So instead of do so much adding, subtracting, okay, I know that I need to add up not, all the not, all the one that is not living in apartment. So that's up and down. So the up and down is, we know is 6, 20, and 23. $623 is the non-male. Total possible outcome is 1450. So instead of, write down the subtraction so much, I'm just gonna go ahead when I count the not living apartment, I'm just not gonna count the repeated number that I just added up and down. So I'm just gonna add these number right here, 278. Plus 157, plus 202, plus 104. So that's 741. So I already subtract off, or not even counting the overlapping portion. Okay, I already not counting these already when I add it. So not living in an apartment, I suppose to add all these horizontal right here. So I'm, instead of doing all that and then subtract, I just kind of not counting this twice in my computation. So if we add up the numerators, not male or not in the apartment is 1364 out of 1450. Okay. So when we're dealing with, so once again, when we're dealing with the word or in probability, you got to think about, okay, are the two events disjoint, also called mutually exclusive, or they are not disjoint? In the previous topic, I began to mention this idea called the complement. I just mentioned it one time. So in probability, the complement rule says the complement of an event E, okay, denoted as E complement, or E with a little bar on top, also means E complement, is the set of all outcome in a simple space that is not in the event E. So whatever is not in the event E, okay, are considered as E complement, the complement of event E. So in my Venn diagram here, right, you can see the big old rectangle box. Things event E is 264. So what is not in the event, so what is in the simple space, but not in the event E, are 1, 3, and 5. So those are called the E complements. Okay, that's the way how you actually look at them. Okay, so complement are outcome that are not in the event. So sometimes it's actually easier to figure out what you don't want. Okay, the complement is what we don't want. If I want to find the probability of E, right, I can find probability of E directly, or I can find out what is not in the event E, which is what I don't want, right? So in a way, to find what you want, you can first find out what you don't want and subtract from 100%, because all probability add up to 100%, like we discussed in topic 12. So that's just one way, this one approach we can look at these probability questions. Okay, so I will show you how to do that just in a minute. So let's say, for example, a card is drawn from a standard deck of 52 playing cards. What is the probability that card will be a heart and not a jack? Heart and not a jack. Probability. So this is only, so this is word and right here. Okay. Normally the word and means we will multiply, but the word and also allows us to think about the two events. Okay. A little bit easier. Heart and not a jack. This one is a little bit tricky. You gotta think about it a little bit. Gotta be a heart and not a jack. There are 13 hearts. There are 13 ways to draw a heart, and one of them is a jack of hearts. So I need to draw a heart. So this is only one event, really. I need to draw a heart and also not a jack. So because there's one card that is jack of hearts, that's a card I don't want also. So that means there are 12 other ways I can draw a heart, not a jack, on the 52 possible outcome. Okay, so you gotta think about that. So I know what I don't want. What I don't want is jack of hearts. So what I want is the other 12 ways, the other 12 cards. Okay, on the 52 possible outcome. All right. So in a way, I kind of figure out what I don't want ahead of time, so I know, the probability of what I want. All right, a coin is tossed 9 times, for example. What's probability of getting at least one head? So I kind of make this a word at least bolded. Okay, so we're gonna start seeing these wording again. We kind of see a little bit, here and there, in one of the topic that we gone through. I think it was when we talk about the empirical rules. Okay, so the word at least one head. So I'm tossing a coin 9 times. At least one head means I can get. So let's think about this. Okay, let's back up. Think about what could be all the possible outcome. If I toss a coin 9 times, and this question will want me to find a head, can I get 0 head? Sure, I can. I can have tossed 9 times, and all of them, none of them is head. Right? I can get just one head. I can get 2 heads out of 9 toss, 3 heads, 4, 5, 6, 7, 8, 9. Right? On the 9 toss, I can get no head at all. 1 head, the other 8 are tails. 2 heads, the other 7 are tails. Right? 3 head, the other 6 are tails. So these are the possible outcomes. I'm saying can happen. I can even flip 9 times, and all 9 of them are head. So at least one head means what I want is one head or more. So I win if I flip all the 9 flips. If I win if I can get one head or more. So all these is what I want. So what I don't want is end up flipping 0 head. So this problem is actually harder to tackle the probability of exactly what I want. Because what I want is a lot of other different ways. Okay. What I don't want is only one possible outcome, is no head at all. So now the question is, how many ways I can get 0 head? So probability of at least one head is take the total probability is always 100%. So that's take a 1, which means 100%, subtract the probability of 0 head. So if I can figure out the probability of getting 0 head, subtract from 100%, then that give me rest of it is what I want. Okay, so that's the idea of a complement rule. Is figure out what you don't want, subtract from 100% to get what you want. Because what you want is a lot of ways. So how many ways can I get no head? Well, if you think about it, if you think about the tree diagram I drew last time, okay, of 3, toss it, how many ways you can have 3 children, or on the homework, tossing a coin 3 times. Okay, to get all boys or getting all heads, it in those kind of problems, it's only one way, right? It's only one way to get them. And that one way is basically saying 1, 2, 3, 4, 5, 6, 7, 8, 9. That one way is saying all tails. So this can only be one way to get 0 head, which means all tails. Out of what's my total possible outcome? The total possible outcome is 512. Now, how do I get 512? Each flip has 2 outcomes, followed by another flip with 2 outcomes. So one event followed by the other. So here we will multiply. So I'm basically take a number 2, means 2 possible way for each flip, 2 possible outcome for each flip, and did it 9 times. So 2 times itself 9 times, 2 to the 9 power. So 2 to the 9 power in a calculator will be 512. That's how I get 512. So that tell you that you know, when you flip a coin 9 times, there are 512 total possible outcomes. Getting 0 head or all tails is only one way on a 512. So if you take one, subtract, if you take one, subtract 512, okay, one we can rewrite as 512 over 512. Subtract 1 out of 512, that should be 511 ways that out of 512 total possible outcome. So what I want is at least one head. So that means I want 1 all the way to 9 out of the 9 flip. Right? I can have 1 head in all the 9 toss, or I can have 2, or I can have 3, or I can have 4 heads out of 9 toss. So that word "or" is telling you to add up all the, you know, the word "or" means I'm going to add up the number of ways to get 1 head out of 9 flip, the number of ways to get 2 heads out of 9 flip, the number of ways that I can get 3 heads out of the 9 flips. Okay, so you add up all those ways together will be 511, which is a lot to count. So that's why it's easier to figure out what you don't want, which is 0 head, and subtract 100%. All right, a standard pair of a die. A standard pair of 6-sided dice is rolled. So I'm rolling 2 dice, okay? So think about this, 2 dice, each die has 6 outcomes, one followed by the other. So 36 is a total possible outcome. What's the probability rolling a sum that is less than 8? So I'm rolling 2 dice, and the 2 dice add up together has a sum less than 8. So if you think about it, when you roll 2 dice, the minimum sum is 2, rolling a 1 and 1. Sum of 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 should be the largest one because it's only 6-sided, right? So if you roll a 6 and the other die you roll is also 6, 6 and 6 add up together, that's a sum of 12. So the total sum of the 2 dice is 12. What my question is asking is what's the probability rolling a sum that's less than 8? Less than 8. So 8 is not included. So all this is what I want. So what I don't want is rolling 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5. There are 5 sums I don't want. There's 6 sums I want. So in a way, you know, we can kind of figure out what I don't want and subtract from 100%. So the idea is take 100%, 1, and subtract the probability of rolling what? Sum of 8, or sum of 9, or sum of 10, or sum of 11, or sum of 12. So we need to add up all these ways, right? We need to add out the number of ways to get sum of 8, 9, 10, 11, or 12. That's what I don't want, subtract 100%. All right, so let's think about this. How can I roll a sum of 8? Let's figure out how many ways we can roll a sum of 8. There's no 1 and 7, rolling a 1, rolling a 7. That does not exist because it's only 6-sided die. So what if I roll a 2, then a 6? That's an 8. Or I can roll a 6 first, then a 2 on the second die. Roll a 3, then a 5. Or I can roll a 5, then a 3. Or my 2 dice can say 4 and 4. That give me sum of 8. So that's 1, 2, 3, 4, 5 ways. Sum of 9. So that gotta be rolling a 3, then a 6, right? The first die can be 6, the second die can be a 3. So that's another way. Rolling a 4, then a 5, or you can roll a 5, then a 4. So that's 4 different ways. All right, roll a sum of 10. Sum of 10, there's no 1 and 9, okay? There's no 2 and 8, because 9 and 8 doesn't exist on the 6-sided die. So sum of 10 got to be 4 and 6, 6 and 4. And of course I can roll a 5 and then a 5. 11 got to be 5 and 6, right? Rolling a 5, then roll a 6 on the second die. Or I can roll a 6 first, then 5 on the second die. There's 2 ways. And sum of 12 is only 1 way, rolling a 6, then a 6. So let's count how many ways we don't want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 ways I do not want. So 1 minus the sum of these together, 15 ways out of 36 total possible outcome. So the 1, you can view 1 as 36 out of 36, right? Minus 15 out of 36. So 36 minus 15 should give me 21 out of 36. So I'm not simplifying my fractions either. I just want you to see the actual number of ways that we want to win out of the total possible outcome. So there are 21 ways to win out of 36 total possible outcome. Okay, let's take a look at your homework. All right, question number 1, 2 events that are what if they have no common outcome? They are disjoint or mutually exclusive, right? So that's coming from the definition. All right, a coin tossed 10 times with probability getting at least 1 head. So that's very similar to this problem that I did, okay? The one I did is 9. This one is asking for 10. Okay, enter your answer as a fraction. Okay, so make sure when you enter your answer, make sure it's a fraction. Use the graphical equation to enter answers and do not simplify the fractions. Okay, make sure you don't want to simplify it. So no decimal, none of that. So it's very much just like the way how I write my answers. Okay, not simplify any fractions. All right, a pair of 6-sided dice rolled. What's probability of rolling a sum greater than or equal to 6? Okay, this time it's greater than or equal to 6. So very similar to the way I just did, okay. Do not enter answer as a fraction, no decimals, and don't simplify the fraction. Make sure you use the graphical equation. In this problem, heart or jack, okay. Probability of drawing a card from the deck. What's probability of getting a heart or a jack? Okay, try that one for me as well. All right, again, fraction answer only, no decimals, and do not simplify the fractions. And try this one just like I did earlier with the tables. Okay, I think there's 2 problems right here. So give those a try. So just real quick, kind of teaching you what is the addition rule for probability. Okay, addition rule, we use the word or. So when we are dealing with the word or, you got to think about the events are disjoint or not disjoint. So if you think about the sum of 2 dice, right? All these, all these events here are all not disjoint. Excuse me, they are all disjoint. Excuse me, they have no common outcome, right? The sum of 8 has ways for the sum of 8, 9, 10, 11, or 12. So just kind of teaching you what it means for the probability of addition rule. All right, thank you for watching.